Hello once again. Welcome to the continuation on the direction or bearing of a vector that I started with you in the previous videos. In the previous videos, we started learning about how to find the direction or bearing of a given vector, which we've done a detailed explanation on it, and we've solved some examples on it as well in the previous videos. And I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to solve another example on it so that you get a perfect understanding of it. So I have example 4 on the board, as you can see. So it means we've already done example 1, 2 and 3 in the previous videos, and I will encourage you to do all to watch the previous videos, because the previous videos lays the foundation, the basic knowledge and explanation that you need about how to find the direction or bearing of a given vector. I've done all those explanations in the previous videos, particularly the first video. Okay, so please do all to watch them so that you can get a good understanding and foundation to be able to handle this session as well, because we are just going to apply the knowledge that we've gotten in the previous videos here to solve the example 4 that I have on the board. Okay, so just do all to watch them so that you can easily handle this also. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and take a look at the question that I have on the board and let's solve it together. Okay, so example 4, it says that find the magnitude and direction of the vector PQ equals -1, -1. Okay, so I'm going to read it one more time. Okay, it says that find the magnitude and direction of the vector PQ equals -1, -1. So we have been given the vector PQ to be -1, -1, and we are being asked to find the magnitude and also the direction of the vector PQ. Okay, so the question is in two parts. Okay, so the first part says that we have to find the magnitude of the vector PQ, and the second part also demands that we find the direction of the vector PQ. And all of this I've taught you in the previous videos. I've taught you how to find the magnitude of a given vector, and also I've taught you how to find the direction of a given vector in the previous video. So we are going to apply that knowledge to solve this question. Okay, so let's go ahead and start solving it together. So I'm going to write down my solution, okay, and we are going to start by finding the magnitude of the vector PQ. Okay, so that's the first part of the question. So the vector PQ is given to be -1, -1. Okay, so the magnitude of PQ, the vector PQ, will be equal to the square root of the sum of the squares of the component of the given vector. Okay, so anytime you are being asked to find the magnitude of any given vector, all that you need to do is to find the square root of the sum of the squares of the component of that given vector. Okay, so as I've written, so the magnitude of the vector PQ equals to square root, then we'll find the sum of the squares of the components of the given vector, and that will give us the magnitude of that vector. Okay, I hope you understand up to this point. This we've done in the previous video, so we are just applying that knowledge here. Okay, so the component of the given vector is -1, -1. So the square root of the sum of the squares of the component of that vector. So it's going to be -1 squared plus -1 squared. Okay, so that's it to find the magnitude of a given vector. So from here, we just need to simplify further. Okay, so let's go ahead. So my magnitude of the vector PQ will be equal to the square root, then you simplify what is under the square root sign. Okay, so -1 square gives +1 plus -1 square gives +1. Okay, then let's go ahead and simplify further. So my magnitude of vector PQ will be equal to 1 plus 1 is 2. So we have square root of 2. Okay, and you know that the square root of 2 will not give a whole number as an answer. It will give you a decimal number. So you can either leave your answer in decimals or you can leave it like this. Any way that you want is the same thing. Okay, I will just choose to leave it like this and add my unit. Okay, but if you want, you can just leave your answer in decimals and it's the same thing. Okay, so my magnitude of vector PQ, it gives me square root of 2 units. Okay, so that's my final answer. Okay, so we've answered the first part of the question, which says that we should find the magnitude of the vector PQ. Now the next part is saying that we should find the direction of the vector PQ, and I've also taught you how to find the direction of any given vector in a previous video, so we are going to apply that knowledge here. Okay, and the first thing to do is to draw your cardinal point. I hope you remember this we've done in the previous videos. Okay, we are going to draw our cardinal point first. So let me draw my cardinal point and let's proceed. Okay, so this is my north, south, west, and east. Okay, then now we are going to plot the component of the vector on the cardinal point. Okay, so for that reason, we are going to consider the vertical line as our y-axis and the horizontal line as our s-axis. Okay, you know that you need your y-axis, s-axis to be able to plot any given point. Okay, so the vertical line here, we are going to consider it as our y-axis, and the horizontal line here, we are going to consider it as our s-axis. Okay, so that we can plot the components of the vector given on it. Okay, so here will be my positive y-axis, here will be my negative y-axis. When I come here will be my negative s-axis, here will be my positive s-axis. Okay, so that's the Cartesian plane. Okay, so we have the y-axis and we have the s-axis, where the y-axis is the vertical line, the s-axis is the horizontal line. I hope the explanation is clear enough and you understand up to this point. Okay, so now the next thing to do is that you indicate your point of intersection, okay, which is the origin. Okay, you use the first letter to indicate your origin. You can see that this is the point of intersection, which is the origin. Okay, so we are going to use the first letter to label the origin. Why are we doing so? Because we have vector PQ, meaning that the starting point is P and we are moving to Q. So vector PQ, you can see the arrow is moving from P to Q, so it means the starting point is P and we are moving to Q, so the origin is P. I hope the explanation is clear up to this point. Okay, so that's why we are supposed to label this origin as P. Okay, I hope you understand up to this point. Okay, so now let's go ahead and plot the components of the vectors that we have on the Cartesian plane. Okay, so we have -1, -1, and I hope you remember that we've already established that the top value is the s component and the down value is the y component. Okay, so given any vector, always the top value is the s component and the down value is the y component. So we are going to pick the s component, which is -1, and we'll come to the diagram and plot it. Okay, then we'll do same for the y component as well. Okay, so when I come to the diagram, I'm plotting -1. Okay, so this is the negative s-axis. So this is not drawn to scale, so just with your imagination you'll be able to locate the -1 at the negative s-axis. Okay, so let's say this is my -1. Okay, -1 here. Then I will come to my y-axis also and plot the y coordinate, okay, or the y component, which is the -1 as well. Okay, so the negative y-axis. Okay, so I'll come here and let's say this is my -1. Okay, and the negative axis. Okay, negative y-axis. So now, after you've plotted it like this, now you need to locate the point of intersection of these 2 points, which is the -1 and the -1. Okay, so we are going to use some short dashes to locate the point of intersection. Okay, so you can agree with me that the point of intersection of the points -1 and this -1 will be here. I hope you understand and you agree with me up to this point. Okay, so now we will label here as Q. Okay, because we have the vector PQ. Okay, so if the origin is P, then of course here will be Q. Okay, so that we can join our line. Okay, so that we'll get our vector PQ. I hope the explanation is clear enough up to this point. Okay, so this is what you need to do to draw the vector PQ on the Cartesian plane. And I hope the explanation is clear enough up to this point. Okay, from here we need to now find the bearing or the direction of the vector PQ. Okay, so now we have established from the previous videos that anytime it comes to bearing, when we are reading on the cardinal points, you always start reading from the north in the clockwise direction. Okay, this I've established many times. Okay, we start reading from the north in the clockwise direction. So for us to get the bearing or the direction of the vector PQ, we need to start reading from the north and we'll end on the line PQ. Okay, that will give us the true or the actual bearing or direction of the vector PQ. I hope the explanation is clear enough up to this point. Okay, so now we are going to read from the north till we end on the vector PQ. Okay, so now we know that this quadrant is 90 degrees. Please follow, it's not difficult. We know that this quadrant is 90 degrees. We know that this quadrant is also 90 degrees. So the 90 here plus the 90 here, it gives us 180, meaning that from the north here up to this point here is 180 degrees. I hope you can agree with me. But here is the case, we are reading from the north up to this point. Okay, so if we know here to be 180 degrees, then of course if we are able to know the angle which is supposed to be here, which let me label it as theta, then when we add it to it, then it will give us the direction of the vector PQ. I hope the explanation is clear enough up to this point. I'm going to go over one more time. All I'm saying is that anytime you are reading the bearing, okay, on the cardinal point, you always start reading from the north in the clockwise direction. Okay, we have the vector PQ, so we have to read from the north till we end on that vector PQ, and that will give us the direction of the vector PQ. Okay, so reading from the north will end here, and you know that from this point to this point is 180 degrees. Why? This quadrant is 90 degrees this quadrant is also 90 degrees. So when you add them from here to here is 180 degrees. But we have to read from here up to the vector PQ to get the direction of it. So knowing here to here to be 180 degrees, it means that when we are able to find the little angle which is supposed to be here and we add it to the 180 degrees, then it will give us the actual bearing or the true bearing of the vector PQ, okay, which is the same as the direction of the vector PQ. I hope the explanation is clear enough up to this point. So we need to find the angle theta which is here, and for us to do that we need to make use of our trig equation or trig ratio that I taught you in the previous videos, which is we're using the tan theta. Okay, so we are going to use the tan theta to be able to find the angle which is here. Okay, but before that, I want you to take note of something, that from this point up to this point is -1. Okay, so it is the same distance that is being repeated here. If from here to here is -1, then of course from here to here is also -1. Okay, as we've plotted. So the distance from here to here is -1. So let me put my -1 here. Okay, so that we can use it to calculate for the value of the angle theta. Okay, so let me clean this one and let me put the -1 here so that I don't get confused. That is from the origin to here. The distance is -1. Okay, and you can also agree with me that from the origin to here is also -1. So for that reason, from here to here also will be -1 because it's the same distance here from here to here, which has been repeated from here to here. So if this point to this point is -1, then of course this point to this point will also be -1. I hope the explanation is clear enough up to this point. So here will also be -1. Okay, so now let's go ahead and find the angle theta using the trig ratio tan. Okay, tan theta equals to opposite over adjacent, so that we'll use it to find the angle theta. Okay, so I'm going to continue from here. So I know that my tan theta equals to opposite over adjacent. Okay, where the opposite is the side of the triangle which is opposite to the angle theta, and the adjacent is this side. Okay, the part of the triangle which forms the base. Okay, so this side is the adjacent, where this slanted side is the hypotenuse. But we are interested in the opposite and the adjacent because from the equation we need the opposite and the adjacent. So the opposite is the side of the triangle which is opposite to the angle theta, which is this side, and this is the adjacent. Okay, so we have both values to be -1, -1. But I have emphasized a lot in the previous videos that when it comes to we calculating for the angle, we don't use the negative values. If there's a negative attached to it, we discard the negative and use the positive value. So here we are not going to use -1. Here too we are not going to use -1. We are going to use +1, +1. Okay, this I've explained a lot, that when it comes to we calculating for the angle, we don't use the negative values. So the negative sign, we discard it away and we use the positive value. So we are going to use +1 and +1 to calculate, okay, and not the negative. Okay, I hope you understand up to this point. Now, the sign there, the negatives or the sign, whichever sign that you will be giving, is just to help you to be able to locate the quadrant which the angle is formed. Okay, so you can see that when we were giving the vector PQ to be -1, -1, it helped us to be able to locate that this is the quadrant in which the angle is being formed. Okay, so now when it comes to recalculating for the angle, we don't use the negative signs, we use only the positive values. Okay, so the signs are just to help us locate the quadrant which we will draw our diagram to get that angle. But when it comes to calculating for the angle, we don't use the negative signs. I hope I've explained enough and you understand. Okay, so let's go ahead and continue. So my tan theta will be equal to the opposite. The opposite is the negative one, but don't forget, we are not going to use the negative one, we are going to use positive one. So we'll discard the negative away and use the positive one over the adjacent. It's also negative one, but we are not going to use the negative one, we are going to use positive one, so over 1. I hope you understand up to this point. Okay, so 1 over 1 is 1, so I'm going to have my tan theta equals to 1. So to get your theta, my theta will be equal to tan inverse of 1. Okay, and from here, you need to use your calculator to get the value of tan inverse of 1. Okay, so let me use my calculator and let's check what we will get for tan inverse of 1. And tan inverse of 1 is giving me 45 degrees. So I'm getting 45 degrees. Okay, so that's my value of the angle theta, which is here. So now that we know the angle theta to be 45 degrees, then of course we can now know the bearing or the direction of the vector PQ, because we'll read from the north till we end on this vector PQ. We know that from here to here is 180 degrees. Okay, and I've explained why. So from here to here is 180 degrees, and we are reading up to this point. So we just need to add the theta to the 180 degrees, then it will give the entire bearing or direction of the vector PQ. I hope you understand. Okay, so my direction, let me continue from here. My direction of the vector PQ, let me write it for, okay. My direction of the vector PQ will be equal to my theta plus 180 degrees. I hope you understand up to this point. So you always start reading from the north and you read till you end on the vector, so the vector PQ. So from here up to here. Okay, we know the angle here to be 45 degrees, and we know that from here to here is 180 degrees. So when we add this to 180 degrees, it will give the bearing or the direction of the vector PQ, and that is exactly what we are doing. Okay, so it will be equal to 45 degrees plus 180 degrees, and that will result in, let me use my calculator to help us get the final answer. So 180 plus 45, it gives 225 degrees. So 225 degrees. Okay, so this is the direction of the vector PQ. It is 225 degrees. Okay, so this is the final answer. So you can just come and write it this way, okay, to make it look nice. So the magnitude of the vector PQ, we got square root of 2 units. Okay, then you bring your comma, and the direction of the vector PQ, we got 225 degrees. Okay, so you put it like this, and that is your final answer. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please follow the page and also subscribe to my YouTube channel, okay, so that any new video that I upload, you can get a notification to watch the video. Okay, I'll see you again in another video whilst we handle other aspects of the vectors. Bye bye.